Trigonometry. This word is divided in two meanings.
Trigon, in Greek, means triangle.
From ometry comes the word metron, which means measure in Greek.
Therefore, trigonometry means the measures of a triangle, more specifically, the measure of its angles and sides.
Since around 3000 BC, scientists had always been trying to understand the stars and all the planets surrounding the Earth, also trying to understand and investigate patterns in their movements.
At that time period in history, everybody thought that the stars and the planets circled around the Earth, when they actually didn't.
Around 140 BC, Hipparchus of Rhodes, a Greek astronomer, managed to discover a system to investigate patterns in the stars.
He used imaginary right-angled triangles that connected the stars to the planet Earth to calculate their movements. This was when trigonometry began.
In a triangle, there are always 6 elements.
These are 3 sides and 3 angles. Trigonometry is the mathematical way to define relations between all of these elements in a right-angled triangle. The triangle of most interest is the right-angled triangle, and it's labeled in the following way. The missing angle is called theta.
We give names to each of the sides. Adjacent is next to the angle, theta. Opposite is opposite to the angle, theta. And the longest side is the hypotenuse.
When 3 elements in a triangle are given, the remaining ones can always be determined.
There are valid methods and ways to find those 2 sides. Instead, the missing angle can be found more easily since the 3 angles of a triangle add up to the straight angle, which is 180 degrees.
Therefore, if we were trying to find x, we will do the following formula and discover that x is equal to 37 degrees.
Trigonometry is good at finding missing sides or angles in a triangle.
There are special functions, sine, cosine, and tangent. For finding any angle, we will use theta. Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, finally, is opposite over adjacent.
Moving the mouse around, we can see how different angles affect sine, cosine, and tangent.
It is a relation among the 3 sides of a right-angled triangle, AB, or inversal, and C.
It states that the hypotenuse squared, the side opposite to the right angle, is equal to the sum of the other sides squared. The theorem can be written as an equation relating the lengths of the sides A, B, and C.
Why is it related with trigonometry? When we expand a right-angled triangle, we need ratios to find the new measurements of it. A ratio is a comparison of 2 numbers. It is the relation of the size of one number to the size of another. For example, if a right-angled triangle has an angle of 30 degrees and its opposite side is of 5, then the hypotenuse will be its double, equal to 10. As an example of similar shapes, if this triangle is expanded and its opposite side is now equal to 10, then the hypotenuse will be now 20, because the ratio was 1 to 2, so every time it will have to be doubled. A clinometer is a device that is used to measure the angle from a vertical, in degrees. It works with the basics of trigonometry, and it only requires you to look through a lens. To find the height of the omega building, we first have to figure out the length of the opposite side. We measure this with a tape measure. Then we find the angle of elevation by using the clinometer. We measured by using the clinometer. From the omega building until the point from where we were standing was 8.89 meters, and the angle of elevation was of 58 degrees.
So, we want to find the height.
The height, or the x, is the opposite side.
And the distance from the omega to the place we were standing is the adjacent.
Therefore, we will need to use the tangent ratio. Tan 58 will equal to x over 8.89.
To get rid of the x, we will do tan 58 times 8.89.
After calculating this, we will notice that the height of the omega building is equal to 14.23 meters to 2 decimal places.
The average height of a normal building is of 3.5. If we multiply 3.5 times 4 because of the floors, it will give us 14.
Our results gave us 14.23 meters, and the real-life building results average is of 14 meters. 4.23 meters were our results for the height of the omega block. We'll subtract 14 meters, which is the average of a building of 4 floors, and this gives 0.23 meters. The degree of accuracy on our investigation was pretty good, since the results we calculated were only 23 centimeters away from the real-life building average researches. Trigonometry is commonly used in finding the height of towers and mountains.
It is used in the navigation to find the distance of the shore from a point in the sea.
It is also used in finding the distance between different objects or spaces. Architects use trigonometry also to calculate structural slopes and ground surfaces.
This is done with trigonometry by using the angle of depression and the angle of elevation.
An actual event that needed lots of mathematics and trigonometry to solve lots of problems was in the building and creation of the Great Wall of China. They used right-angled triangles to calculate length of slopes and other measurements. They needed to use these formulas because they wouldn't be able to measure such long distances. This and so many other reasons show why trigonometry is so helpful in class and in real-life events.